you.
Wow, what kind of dog is she?
Oh, she's a mini Australian Shepherd.
She's gonna be so big when she grows up.
Actually, she probably won't get much bigger, maybe a little bit.
Dang, you should probably get her tested. That's not normal.
Really?
Yeah.
Okay. Thank you.
No problem.
Come on, Bella.
Hi. Who do we have here today?
This is Bella Brown.
Hi, Bella. And what seems to be the issue?
She's having some problems with jumping up now. She's always been small, even as a pup, but now she's kind of young still. She's 8 months old, and she is having problems get up, and even though she's a runt, she's still really tiny. So just wanted to get her checked out because she's still mistaken as a toy.
Yeah. Okay. Well, her heart sounds good, so I'll have the doctor come and take a look at her.
All right, sounds good. Cool.
Hi, how are you doing today?
Good.
I hear we have some concerns about Miss Bella Brown.
Yeah, she's having some problems with, it seems to be muscles and joints, but
Yes, the vet tech gave me an idea about what's going on. I'm going to go ahead and take her on back and we're going to do some blood work if that's okay with you and look at all of her vitals.
sounds good.
Awesome. Come here. So after looking at all the lab work that we did on Bella, we have diagnosed her with Duchenne muscular dystrophy.
Yeah, and so it's basically a genetic disease where her muscles are going to degenerate over time, and that's why she's been having trouble jumping and just walking in general.
Okay.
Let me give you an inside look of what's happening inside her body.
Okay, that would be very helpful.
The root cause of muscular dystrophy is found in the DNA in the nucleus. Here's a strand of DNA, and you can clearly see the 4 nitrogenous bases. Adenine always pairs with thymine, and cytosine with guanine. During replication, you can get a mutation. This is where the sequence gets replicated incorrectly. This can be troublesome since the DNA sequence codes for your amino acid sequence, which can be changed by the mutation. Amino acids make up proteins. In this case, we focus on dystrophin, which helps absorb shock in your muscles. Without it, your muscles wear down. Sad. Let's let office characters represent a specific amino acid sequence, which makes dystrophin. A specific DNA sequence codes for the dystrophin amino acid sequence. Each office character or amino acid gets along well with the person next to them. This allows the office or protein dystrophin to function properly. However, if there is a mutation, Michael can end up next to Toby, who he hates. This messes up the whole flow of the office or the amino acid sequence, and the protein will not function. So currently there's a lab that I know of that is doing this CRISPR research, and I think it would be very beneficial to get Bella involved in the experimental trials, and I think you'd see great improvement. Is this something you're interested in?
Yeah, I'd actually really like to get her involved in it.
Wonderful.
Hello, today we're going to show you a brief explanation on how CRISPR works.
Okay, let's get into it now. CRISPR is an enzyme from bacteria that is programmed to remove the specific sequence of a DNA. We can identify the mutated DNA sequence in CRISPR and find it and remove it. Here is a CRISPR finds the mutated DNA and cuts it out. Cut, 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 cut. Once it is removed, the DNA sequence will no longer have the mutated part.
In the future, we hope to use this technology in human children and not just dogs. Once we have engineered a CRISPR enzyme that will work specifically for their body, they now have the CRISPR enzyme necessary to treat their specific DNA mutation that is causing the dystrophin gene to not work, and they will become healthy again.
So we recently just got the serum from the lab, and I'm going to do an injection in her back leg muscle.
Okay.
And then you should see an improvement over the next couple of weeks and let us know how she is doing.